All right. I use this first page here with the graphs to explain why the derivatives of the trig functions are what they are. Continuing the theme of I always put more on here than we actually need, because you're Calc BC and you did learn them last year, I'm going to skip the why behind it, and we're just going to go to what they are, okay? Because we don't have time for that. Now, if you are interested in me explaining why these are what they are, I will be more than happy to do that for you. Do you all understand? Okay, but we are going to just skip that first page for right now. We're going to go to our bubble sheet, and I'm just going to tell you what they are, because in BC, we just don't have time for that, and you did see them last year, okay? So for trig, we're going to use the gigantic bubble, because there's a lot for us to put in there, okay? We're going to put derivative of, you're going to be okay. We're going to put derivative of each of the 6 trig functions.
Well, all right. So I have a question.
I'm a little nervous about a question because I didn't do anything yet, but go ahead. I always get nervous when someone has a question before I've done anything. I'm like, okay, go ahead.
What about arctan and?
I'm going to get to that.
So that isn't included in.
Same bubble. I just do it all at once, like ripping off a Band-Aid.
Well, because I remember last time we actually were there for trig function, and then I was thinking about the arctan and arctan.
Okay, so let me clarify that then. That's word semantics that we're getting into. There are 6 trig functions. There are 6 inverse trig functions. Those are inverse trig functions. They are totally separate functions. We should have the computer closed now. That should be done installing. Is yours done installing? Yeah, okay. So there are 6 trig functions, and then they each have an inverse to them. That's what arc is. So you can, we're getting ahead of ourselves. Can I get to that in a second? I was going to talk about that. No, you're fine. I love when we're ahead of ourselves. All right. Did we write down all 6? I get told that I write too fast, so you have to tell me if I write too fast. All right. Derivative of sine. I'm just going to throw it out there because you did learn it last year. What is derivative of sine? Cosine. Perfect. Usually goes well. Derivative of cosine, negative sine. All the cos get negatives. This is an important.
Yeah.
Derivative of tangent. Does anyone remember that one?
Squared.
It's secant squared. All right. Here's the little acronym that I get that people will sometimes use for the secant and the tangent, which is like, hey, I need to tell you something. Positive, so there's not a negative. If you cover up the one you have, it'll give you what you want. So if I cover up the t for tangent, it's secant squared. Do you see that? Now, if we go to do secant, I'm going to do this one next. It is secant tangent. And watch this. It's positive. If I cover up the one I have, so look, if I cover up secant, then the derivative is secant tangent. Do you see that? Now, if you can remember those two, cotangent and cosecant have the exact same relationship, but they are negative. So do you see how tangent is secant squared? Cotangent is negative cosecant squared. They have the same relationship that these two have. So how secant is secant tangent, cosecant is negative cosecant cotangent. So if you can remember, and then the cos have the same relationship as those ones, except they're negative. Okay? Do you see what I'm saying? Or if that didn't work for you, forget that and then just memorize it. I'm not able to teach memorization. That's not a teachable thing. All I can do is show you this, and then you have to take it and put it in your brain however things get ordered. The way thinking works, we store things based on similarities and we retrieve them based on differences. If that helps you like organize your bookshelf in your mind at all, okay? But all I can do is present this and go, here it is, and you have to do the rest, okay? Now we're gonna do 2 of the inverse functions. I'm just gonna fit them down here. We're gonna do inverse sine or arc sine and inverse tangent or arctangent. And do you know the other way they can be written instead of with an arc? Do you know what the other? Yeah, with the little -1 in there. Do you know what I'm talking about?
I think it's
Well, it's a personal preference. So either way, you can't be wrong, but just you need to know they mean the same thing. Okay. Arc sine derivative is 1 over square root of 1 minus x squared. It comes from a right triangle and Pythagorean theorem. Do you know a squared plus b squared equals c? That's where it comes from, okay? And arctangent is 1 over x squared plus 1. A couple of years ago, they threw an arc cosine in. So if you want to write this one down, you can, but I feel like this is already overload. Arc cosine is the exact same as arc sine, except since it's a co, it will have negative. Arc sine and arc cosine are the exact same, except co has negative. Okay, so if you want to write that down as well, you can, but it's the same thing. All right. They haven't called us to go hide in the corner yet, so we're going to try a couple of examples. So we're on number 1 here. And again, I might not do every single one of these. Maybe we'll just do the odds. Can we do the odds? Does that work for you? Okay. Again, I just throw more than we need on here just to have a lot. All right. 1 over x squared plus 1. And again, it's all being recorded, so you can always rewatch it. Yes, go ahead.
I remember seeing one like that.
So yeah, that one is secant. And these are the only, well, up until again a few years ago, arc sine and arc tangent were the only two. Then they threw in an arc cosine. The other ones aren't part of the standards.
Really? Oh my God, we learned that for no reason.
Yeah, you made us go hard.
Wow, we're not going off on a tangent. What rule do we need for this one? Good. X squared is the first function. Sine is the second function. So it is the first thing. Derivative of the second. Cosine, perfect. Plus the second function, and then derivative of the first. Cool. We'll just do the odds. So we'll do the next one below that. What rule is number 3? Chain. Now listen. The analogy I always use for this is, and I probably brought this up last time. You ever watch a cartoon when you were a kid? There's a small fish coming around, and a medium fish comes and eats it, and then a bigger fish comes and eats that one, and you bring it. But or the Mauritian dolls, the nesting dolls, the Russian dolls, you know what I'm talking about? There are 3 links in this chain. The most outside is the 4th power. Do you see that? 4th power. Inside of that, like the next fish that got eaten is cosine, and inside of that is 9x. Okay, perfect. You're all on board with me. So we're going to do the outsideist to the outsideist, the most outside one first. So that 4 is going to come down. It drops to a 3, and all of the guts stays the same. The insides all stay the same. Good so far?
Yeah.
Okay. Put a little chain rule dot. Now we're doing derivative of cosine. Is there a power? No, we did the power. That fish is gone. That outside fish, that outside function is gone. Just derivative of cosine, which is negative sine of 9x. Again, the guts stays the same. Another chain rule dot. And then you do the derivative of 9x, which is 9. Cool, you guys handled that. Good job.
Oh, so what's the difference between like 9x having parentheses? If I'm gonna load that, then sin x 9.
So you can write sine of x like this if you want to. But usually when it's just an x, you won't see it. But I call them hubs. You can always give more hubs. You can put parentheses around anything you want. But typically if it's just x, we don't put a parentheses. Okay? What rule is this one? In addition to being trig, quotient. All right, if you remember where it starts, you will likely get the rest of it. It starts with the denominator. So denominator times
4.
4, derivative of the numerator, minus, good, numerator, derivative of the denominator. It's a so it's negative. Cosecant squared. We just went over it. You don't have it memorized yet. It's a lot. Okay? All right, over the denominator squared. Now you can either write it like that. When you square the trig function, the squared goes like in between. Or if you want to write it like this, that's fine too. Those mean the same thing. Okay, so whichever is your preference. But here, let's have this conversation right now. You cannot write it like this. Why is that wrong? You're only squaring the x, not the rest of it. So don't do that. Each of these is okay. All right, so for arctangent, it is 1 over, I guess I should put f of x equal, or f prime equals. Now your rule is gonna say x squared plus 1. But when it says x squared, it means whatever stuff is in the problem squared. So since there's like a 7x inside of there, it's gonna look like that. Do you get what I'm saying? It's not just x squared, it's the stuff squared. And then because it's a chain rule, you're going to chain rule on the derivative of the stuff inside, which is 7. Now, normally I'm not like, oh, we have to clean these up a whole lot, but it would never look like that in a multiple choice situation. Where would they put that 7? Yeah, that would be in the numerator, and then you would square the 7x, which would be 49x squared plus 1. I'm going to need for you to face forward and not talk while I'm teaching. Thank you. We'll do the arc sine one as well, just because those can be weird. It's the same thing. There's going to be a chain rule. So it's going to be 1 over big square root. And the rule is going to say 1 minus x squared, but it's going to be 1 minus like that stuff squared. So I'm going to try and skip the middle step this time and just have us jump there. If you square this, you're going to get 9x squared. Okay, so I have to keep pausing the recording. Let me back up a second because we keep on getting interrupted by the announcements here. All right, so it's going to be 1 minus this stuff squared, which would be 9. And then you have x squared squared, which would be x to the 4th. And then instead of putting a little chain rule dot and putting the chain rule off to the side, I'm going to just put it in the numerator. What is the derivative of that? Yeah, 6x. Good. You know, we'll do both 9 and 10, and I'll cut it off there. And then when I get home, I'll reconfigure our schedule and figure out what we're going to do. All right. What is this one asking for? I don't want to read to you. That teaches you to not read. Good. What 2 things do you need? Point and a slope. Good. So our point is going to be at pi over 3. There's going to be a unit circle in this one. Yeah. Now, hold on. I'll get us there. We're going to take pi over 3 and plug it in. Now, pi over 3 times 3 is going to just be pi. All right, I'm going to talk you through this. You're going to be okay. Up, down, left, or right? Where's pi on the unit circle?
Left.
Left. Okay, left. We're there. Cosine is what part of that? X, which is -1. Now you have to take -1 to the 5th. Is that -1 or is it +1? -1. Perfect. What would make it be a +1? Perfect. Okay. Slope comes from the derivative, so we're going to find f prime. What rule is it that we have going on? How many links? 3. The most outside is the 5. We're going to do that first. Bring the 5 down. It drops to a 4. Everything else stays the same. All the guts stays the same. Chain rule dot. Now we're doing derivative of, perfect, negative sine 3x times 3. Cool. Now here's the good news. If you plug pi over 3 into that, look at this part right here for me. Pi over 3 times 3 would just be pi. Again, that's on the left of your unit circle, but sine is what part of the point? It's the y value, which is 0. So your slope actually ends up being 0, because I mean anything times 0 is going to be 0, and here's your equation.
How do you get that over 0 again?
If you take pi over 3 and plug it in right here, you get sine of pi, which is 0. So I don't really even need to look at the rest of it, because anything times 0 is going to be 0. I know if this portion of it is 0, the whole thing is going to be 0. Which actually, how else could you write this? If this whole side is 0, and you move this plus 1 over, yeah, you would just have a horizontal line at y equals -1, because it's a slope of 0. Right, you know, this will be a good amount. We'll finish this one, and then I'll just have to, it'll be my job to figure out how we're going to fix it. All right, at what values does this function have a horizontal tangent line? I kind of have this problem lead into this one. What is the slope of a horizontal line? 0. So we're going to set f prime equal to 0. Follow-up question. What is it called when you set the derivative equal to 0? Our answers will be called what? Critical point. Right? So what is the derivative of just plain x? 1. And then plus derivative of sine cosine equals 0. So we're going to subtract over the 1. Again, I made the other problem lead right into this. You need a place on your unit circle where cosine, which is the x value, is -1. It's the one we just talked about. Pi is your answer. Technically also 3 pi and 5 pi and 7 pi and 9 pi and -pi and -3 pi and -7 pi. Get what I'm saying? Because it's a...
Well,